Hello and welcome to today's Knowledge Bank, Building Services for a Net Zero World. Today's session is hosted by Rupert Mackay from DMG Delta. This session will examine different types of heating and cooling systems, how to maintain them effectively and the relevant legislation that applies. If you have any questions, please submit them via the Q&A button at the bottom of your screen, and Rupert will try to get through as many as possible for you. The session is being recorded today. The recording will be available later today for anyone to watch who would like to watch the session again, or for anyone who has missed the live session this morning. I will now hand you over. Good morning, Rupert.
Good morning. Thank you, Vicky. That's a good introduction. Morning, everybody. I'm Rupert Mackay. I'm a director at DMG Delta. Hopefully, you can see on the screen the opening slide. You will see that there's two people there. There's myself and Paul. Paul is absent. He sends his apologies. He's had a crisis at home. He's had to take his wife into hospital. So it will be me running through this and presenting Paul's section on his behalf. We are both experienced building services engineers, so I think we'll be able to cope without him. So the topic today, building services for a net zero world, a very relevant principle. Everybody, I think, is probably tuned in to COP26 and all those activities up in Glasgow. This session is meant to reflect a lot of the discussions that are happening up in Glasgow and the impact that building services have on our carbon targets and the relevance under the net zero. Everyone, I think, probably is familiar with the principle of electricity or gas and the use of fossil fuels to supply typically electricity or hot water, heat, and a number of aspects that result in global warming. So the agenda for today, it's estimated that currently about 32% of the UK's total greenhouse emissions come from buildings. That figure of 32% seems to vary depending on where you read, from between 30% and 40%. This session will cover the background, so net zero and the relevance. So why is this so important? Heat and our dependence on natural gas. That's the prime driver. We're going to be touching on electricity, but it's primarily going to be gas because heat is a huge contributor to the carbon in the environment. The alternatives, a brief touch on that. We're running into maintenance and relevance and why we should be maintaining this plant and the benefits of doing that. We're going to talk about best practice and standards. And then there's going to be some questions and answers. If a number of questions come through and there's a sort of flood of them, Vicky will let me know and we can discuss it. So moving on to the session boundaries, we will focus on heat, as mentioned. Heat is viewed as one of the main contributors of carbon. So the buildings being heated will use more gas or fossil fuels, which affects the environment. So one of the key objectives is delivering low carbon heat. So we will emphasize heat networks. We're going to talk about the government key objectives. So we have a few slides that cover that. We're going to look at the main contributors to the emissions. We're going to do a heat networks feature. Heat networks is viewed as the government's almost default position. We all need heat in our homes. How much heat and at what cost? How can we reduce the emissions associated with heat? What we're not going to cover in detail is other elements of building services world. So typically lifts, extract systems, fire systems, lighting systems. They all come under this generic term of building services. However, they do have limited impact when compared to carbon associated with the provision of heat, hot water and cooling. So as a general sort of rider on that, a lot of those services use electricity. Electricity and motors and that sort of thing, by comparison to heat, has a limited impact. So moving on. Okay, so what is net zero? So very much part of the news at the moment, but what does it actually mean? It means the balance between the amount of greenhouse gases produced and the amount removed from the atmosphere. For those that have an accounting knowledge, it's a little bit like a balance sheet. So what we put in and what we take out, we really want to be at zero. The point being not to contribute any more carbon to the atmosphere, and the target is by 2050. So the UK reaches net zero when the amount we add is no more than the amount we take away. 100% of the UK building stock needs to be decarbonised by 2050. So the policy and the strategy from government is to look at all elements of building, and there is a white paper that's been produced. There's also a heating strategy document that's just been released as well a few weeks back, looking at how buildings are going to be targeted and what needs to be done to decarbonise them. There's going to be substantial changes to the way we build, manage and heat our homes. So typically building, a lot of carbon release there, typically the concrete curing process and carbon dioxide, but on an ongoing basis, the heat. So the legacy issues of the way we build our buildings. Okay, this is an interesting infographic. We won't spend too much time on it. This comes from a body called the Climate Change Committee. This is independent of government, but funded to deliver information about how our activities are affecting our environment and the emissions. An interesting one up the top, which hopefully everyone can see, is this little arc here, which details the effects of 1 degree, which is broadly where we are at the moment. 1.5 degrees C is what we're trying to contain it within, and then the impacts of going further beyond 1.5 degrees. So that sets out in a clear visual format where we need to focus. The worst is up here, 4 degrees C, which is a disastrous scenario, which obviously we can't go there. But hopefully these guys, and I think in Glasgow, there's sort of 100 world leaders there, will come up with some good solutions and good agreements on how we can deal with it. So UK's commitment to climate change. As a country, we're really pushing ahead with this. So 2008, this is where it started. This is the Climate Change Act. It was passed by an overwhelming majority of, in November 2008, the Act committed the UK to reduce greenhouse emissions by 80% by 2050. I think that's now up to 100%. Paris Agreement signed. UN members agreed to keep global temperature rise well below 2 degrees and pursue best efforts to limit the increase to 1.5 degrees C. Net zero by 2050. So the UK became the first major economy to do this, passed the laws, and we are leading the way there. We had a 10-point plan, which was presented by Boris Johnson to a huge fanfare, and it gives us an idea of the technologies that are going to apply and various options we have to decarbonise. 2021, UK's 6th carbon budget, new target set, new target to cut emissions by 78% by 2035, 15 years earlier than previously planned. So that timeline's been reduced. There was an energy white paper released at the end of last year, and I think we've just had a heat strategy document released a few weeks back. The previous energy white paper, I think, was in 2008, 2007, somewhere around there. And now we've got the COP26 going on in Glasgow, and we can all follow that on the news. So, a 10-point plan for a green industrial revolution. We've got the advancing offshore wind, so this renewable technology integral to our overall strategy. We're going to focus in on low carbon hydrogen, so that will deliver a lot of solutions, and the prime one being it's not a fossil fuel. Delivering new and advanced nuclear power, that is fossil fuel free, although the construction process uses a lot of concrete. Point 4, accelerating the shift to zero emission vehicles. I think everyone's seen electric cars around, and certainly in London, you can see a lot of vehicles that are charging up. Public transport, so cycling and walking, all going to be part of our future. Jet zero and green ships. So the way we fly, what we do, traveling. Point 7, which is more relevant to this discussion, greener buildings, which we'll dig into in a second. Point 8, investing in carbon capture, usage and storage, typically planting trees or storing carbon underground. There's lots of innovation coming in there. Protecting our natural environment and green finance and innovation. So releasing money to allow new technologies to be available on the same platform as existing technologies, but we need to fund that to make it work. And typically with wind turbines, the initial cost of that technology is very high. Now all of the development phase is out of the way. They are very much financially viable. Okay, so point 7, the greener buildings. It says that we will go with the grain of behavior and set a clear path that sees the gradual move away from fossil fuel boilers over the next 15 years as individuals replace their appliances and offered a low carbon, more efficient alternative. So all the emphasis here is about low carbon. The initial issue is that we can't get away from carbon stroke fossil fuels. So policy impacts, we are setting an ambition of 600,000 heat pump installations per year by 2028. This is going to be a tough one to achieve, but the objective is there to try and install all of these heat pumps, and that's over whatever 7 years, an enormous number of heat pumps. It's going to be a challenge. The future home standard, that will encourage developers to work according to certain standards, and hopefully we can reduce the amount of carbon going into the atmosphere by building better. So we've got a few target milestones. This heat and building strategy, which has just been done, which is good. 200 pages of sort of quite detailed narrative and explanation. It looks well thought out, but it's a really good start. 2021, launch a world-class energy-related products policy framework, which we will push for products to use less energy resources. So this is all the story about low carbon, making everything more efficient and not wasting energy. By 2032, in short, the public sector has reduced its direct emissions by 50% compared to 2017 baseline. So that's government leading the way, which is good. So for the UK, our issues are dependence on natural gas. Heat is the largest single source of carbon in emission terms. So anything that we can do to reduce that has to be a positive. Heat is very much on the government's radar. This session is intended to look at the impacts of heat and how through maintenance and all the associated activities, we will reduce the emissions. Okay, heat currently accounts for over 1/5 of the UK's carbon output. So that's the impact of heat we have. It is recognised that 85% of the UK's population heat their homes via connection to the gas grid. So we have the fossil fuels, the convenience of gas, North Sea oil, so North Sea gas or gas from Denmark, or gas coming in from liquefied natural gas, LNG. Fortunately, we're not that dependent on the Russians, but we have a massive need for gas. So everything is driven by gas at the moment. Fossil fuel boilers will be phased out over the next 15 years to be replaced by low carbon alternatives such as heat networks, heat pumps, and electricity. So many apartment blocks will have flats, units with independent heat solutions. Much of the new building stock now that's been constructed steps away from that, and the independent solution is not considered acceptable, and heat networks are the flavour of certainly the moment. We are seeing a few heat pump solutions coming through on a communal basis, but that technology is still evolving, and the engineering associated is in its infancy. The thing about electricity, is that we can generate electricity by alternative means, so renewable or nuclear, as opposed to fossils. So having that flexibility is good. It's unlikely one technology will dominate the low carbon heating sector. So that if you look at the horizon, the emphasis is to try and apply some resilience to the energy sources. So for instance, today, typically very little wind outside, those turbines will not be doing an awful lot of generating. However, there'll be other factors that help. So what are the alternatives to gas boilers? Okay, heat pumps, as I've mentioned, do have the benefits with the electricity. District heating, this is the heat networks again, particularly suited to larger apartment blocks. It's got the economies of scale, generating energy in a centralized location and distributing it to more than one final customer. The beauty of the district heating is that whilst it might be low carbon now, the possibilities are that with the innovation, we get a new product of heat generation that's zero carbon. You can swap out a lot of units and put them onto a zero carbon solution. Hydrogen, this is a long-term holy grail. There is, I think, a hydrogen town planned for 10 years' time. Whether that is indeed achieved, obviously we don't know, but fingers crossed that can happen. Hydrogen, if we're able to develop it sufficiently so that it can replace gas, the benefits are significant. It will arrive eventually, but it's likely to be a bit of a slow burn. There's other technologies. We've got anaerobic digestion, which is big in Germany, energy from waste, which is increasingly popular, and then we've got nuclear. We have an interesting fleet of power stations, some of them a little aged. This slide looks at the nuclear capacity to 2035. So that's the existing fleet. We are reducing the generation capacity, and then hopefully when we bring on Hinkley Point C, we'll see an increase, okay? But that just shows you over the next 15 years what happens with that zero carbon solution. Now, this is an interesting plan. This is comes straight out of the government's heat and building strategy. I'm not going to go into this in any great detail, other than you can see that the technology there, which the government's really focusing in on, is heat pump, hydrogen, heat networks, and bioenergy. So this is another good infographic. This is again produced by the Committee on Climate Change. And these guys are very succinctly describing what happens out in the low carbon heat world. This will come in the pack after the presentation. So looking at this technology that's coming through, so Boris Johnson has these ambitious plans for heat pumps, 600,000 of these things a year. Heat pump manufacturers are rubbing their hands, and they will certainly be hitting their Christmas bonuses, but it's I think very much dependent on take up. So 600,000 heat pumps installations by a year by 2028. Practical limitations of the equipment supply, so and the labour, that is going to be a challenge. Currently seeing some innovation coming through. There will be funding for air source heat pumps, which helps. We have seen, this is very recently, interesting designs coming through where there's 30 plus air source heat pumps located on the roof of a building. That's a building with 100 units in it. And they are using this technology, and it is cutting edge technology. The concern for us is that the cost to residents seems to be quite high when compared to the alternatives. In our view, air source heat pumps are more suited to a single dwelling at this point, and in the sort of communal sector is a difficult one to justify, primarily because of cost. As we say, unit rates to residents are very high. Moving on, so heat networks and energy centres. This is the big one, and really from the point of view of government, and certainly property managers who manage large blocks of flats. When we say large blocks of flats, we're sort of talking 50 units, although you can get heat networks that can supply 2 or 3 flats and up to entire districts. So maybe 3,500 units supplied from a centralized point. So a combination of energy sources can be used in addition to natural gas, so typically biomass, dated air source and ground source heat pumps. Heat networks can also harness waste heat from energy centers, factories and rivers. So if there's some form of industrial process going on nearby to a central population, that heat can be recycled as opposed to being pumped out into the sea or into a river or allowed to cool. So innovation-wise, I think it's certainly with Scandinavians, do a lot of heat recovery and use of heat that would have otherwise been wasted from typically a pulping process and putting it into people's houses. So the increasing movement towards heat networks with the introduction of the Heat Networks Metering and Billing Regulations 2014 plus amendments. So you can see the government is really pushing ahead with this. So specialist government set up within BEIS, that's the Business Energy Industrial Strategy section of the government. There is a dedicated unit called the Heat Network Delivery Unit. Very much becoming part of the landscape. Okay, so heat networks and energy centers, when maintained and operated correctly, this is a key factor, outperform conventional gas-based systems. So they can provide a reliable supply at an affordable cost. The key being that this should be on a low carbon basis. From handover, performance should be optimized to ensure that the system benefits from fewer energy losses, reduced carbon emissions, and system inefficiencies. So this is an infographic that's been put together by the ADE, which is the Association of Decentralized Energy. That just summarizes the expectation of what's going to apply on heat networks. And for you guys as property managers, you can see 8 million customers by 2030, okay, which is going to meet 17% of our heating needs, okay, which is going to be massive, okay. So that's the importance of heat networks, okay. Here we have the Climate Change Committee again, save 700K tons, 700,000 tons of carbon a year, could serve 8 million customers by 2030, could provide 20% of UK heating needs by 2050. So heat networks are technology agnostic. The fossil fuel heat source can be retrofitted with a low carbon alternative, typically a hydrogen boiler, okay. Right, combined heat and power, now often shortened to CHP, very relevant. This is an integral solution within many heat networks and is often overlooked. This has been included in the slide pack because there's an increasing relevance of the heat and the CHP because of the electricity generation capacity. So where buildings are currently undergoing a contract renewal for electricity, typically with the increase in rates, there's an opportunity for anybody who operates a CHP unit to increase localized energy generation and supply the building with lower cost electricity. So often integral to the energy center, provides for low carbon heat generation. So the beauty is that you get both heat and power out of CHP. So you're using what could have otherwise been wasted at the power station. That means heat. So it generates both heat and electricity very economically. Used to be popular, but has late fallen out of fashion, mainly because people struggle to understand the technology and get the sums right and the modeling. The modeling is critical to this. They can be very cost effective, but get it wrong and it costs you a fortune. Cost your lessees a fortune. Inherently complicated modeling and requires specialist input. So you'd need to talk to somebody like us to get the best answers on how to operate your CHP. Has a very definite position in low carbon generating. generation, but only if people know what they are doing. Can cost more to run than conventional boilers when used incorrectly. So if you get that operation wrong, you can expect some huge bills. Okay, air conditioning systems. So typically cooling, but not limited to cooling, can include heating by electricity, but generally modern blocks will have heat networks and a cooling system installed. Many new builds now have heating and cooling. Bizarrely, they're putting a cooling in to counter the effects of having a heat network in the building, because the building is so well insulated that and the pipes are not sufficiently well insulated that the buildings overheat. Cooling where water is the medium. This is covered by regulations. So as opposed to a refrigerant, you have water circulating, that's treated water, and that is covered by the heat regs. Okay, some cooling systems run on refrigerants. These are outside of the heat regulations. We'll touch on the heat regulation shortly. The use of electricity can operate very efficiently, so they can operate well. The coefficient of performance can achieve savings on costs. So the way that an air source heat pump or these air conditioning systems work is by a coefficient of performance, which means that you can get more out of your air source heat pump or your cooling system in terms of energy than you put in. So 1 kilowatt of electricity used on your air source heat pump or your air conditioning system might well generate 2 kilowatts. It's essential to understand where the electricity costs are coming from. Okay, because you might have a supply from a CHP. Okay, so right now getting more into the life cycle of an asset. So when we talk about these items of plant, they are now in the realms of an asset. They are integral to the building and very valuable aspect of the building. The building won't function without them, or won't function particularly well. But the point is that this is an asset and must be viewed as such. So requirements specified, typically a heat network, design to meet the requirements, construct and commission, it's capital investment. Okay, it's got to be operated and maintained, so that's a running cost. Asset life depends on equipment selection, standard of installation, and ongoing maintenance. Various guides apply for longevity. So it's important to try and follow the designer's intention. And when the designer selected items of plant, you've got the full range. You could have a very basic piece of equipment to a very sophisticated, expensive piece of equipment. And the life will quite often depend on whether it's a cheap piece of equipment or an expensive piece of equipment. So you could be looking at a couple of years versus 20 years. So that needs to be determined. Everything has to be done according to the manufacturer's O&Ms to ensure that you get the most out of it. And then at the end of the life, you decommission it, so replace it. Okay, so the importance of maintenance. So one of the key factors, health and safety and reduction of risk to all stakeholders. So everybody that is interfacing with this equipment, typically a maintenance engineer, who will go in and maintain the plant periodically, to a concierge who will go and inspect plant, to a resident who might go into that area, to the property manager, or any other person who's involved with it. Reliability for the consumer. So the guys who get the benefit from it, so the main stakeholder is the lessee, they need to receive a reliable service, and if maintenance is done properly, hopefully that will improve the standard of service. So prolong the asset life and keep capital replacement costs down. So maintenance generally, if it's done well, will extend the life of the asset. Limited maintenance or no maintenance, and you can expect the asset to probably fail fairly quickly. So maintenance is an investment, and it will hopefully keep the plant going for longer. It also maintains efficiencies and keeps fuel costs down by optimizing operation. So heat networks typically where residents are charged according to their consumption, quite often now through a heat meter, you can, as a resident, make a direct connection between what you charge, your charge per kilowatt hour, and what you can buy, say, with natural gas, and how much that costs you per kilowatt hour. Okay, so the awareness is very much higher. It meets low carbon credentials, especially resulting from use of fossil fuels. So, for instance, an energy centre that's fueled by natural gas, if the combustion tests are not completed and the burner typically is not optimized, you can expect that plant to run inefficiently. Not immediately obvious, but once people start to review the costs of the fuel supplied to the energy centre versus the heat received by the residents, because you've now got this added transparency, it becomes far more obvious that the maintenance is possibly not up to scratch. Moving on. So, planned preventative maintenance, PPM, a term often bandied about. It's very relevant, and the point is to have a schedule of activities that deal with certain aspects of plant maintenance, which is driven by task schedules and manufacturers' literature. So, ensure health and safety elements are in place and plant operation does not pose a risk. Define tasks to be undertaken on a scheduled basis. So, planning over, say, for instance, a course of a year, saying, right, okay, we will strip down that boiler, we will do the annual service on that boiler, or we will do a quarterly check on those pumps, a schedule of activities. Completed according to the operating and maintenance documentation. Hopefully, the installer and the builder, particularly in new building, has provided this information. Quite often in older buildings, that's just not available. Over the course of time, it's disappeared. Okay, defined by the installer and handed over on commissioning and handover. Critical information that will prolong the asset life expectancy. So there will be issues of water treatment, for instance, and running speed typically that will be defined by the installer and manufacturer, but needs to be maintained. Undertaken to various standards, typically SFG 20, which is a task-based process. The point being that an SFG 20 comes from, I think, the Building Engineering Services Association in conjunction with the Chartered Institute of Building Services Engineers, and defines how, for instance, a particular type of boiler will be maintained. Essential to check O&M information. This is, as I've said, fundamental to the longevity of the plant, that O&Ms are checked if they are available. Okay, so regulation and best practice, a few items here. So we've got legislation to guide energy performance of buildings. So building regulations 2010 Part L, conservation of fuel and power. Energy performance of building regulations 2012 requirements for the EPC, which is an item of discussion in the heat strategy document. It's equipment specific regulations. So you've got these heat network metering and billing regulations 2014 plus amendments. That is probably one of the biggest changes recently. So requirements to measure heat at the point of use, so within the apartment. Historically, gas charges on a communal network were generally charged to a service charge, and then the lessee would pay their proportion according to their percentage under the lease. That's now out of the window, and you have to bill based on consumption. Health and safety legislation, and there's a lot of it, but key, you've got to do the statutory annual gas safety checks. That's absolutely essential. F-gas regulations, so that's to do with air conditioning, heat pumps and cooling systems. And eco-design for energy-related product regulations to improve boiler efficiency. So here are a few specific codes. You've got the Guide M from CIBSE, that's the Chartered Institute of Building Services Engineers. That's the body we work with, and we're looking to deliver their practices and best practice. You've got the heat network, the code of practice for the UK. So very specifically for heat networks. This is an updated document. Again, that's a document we work to. And then you've got these heat network regulations. So selecting the right maintenance partner. You've got to remember heat networks are not just large boilers that supply a number of flats. They are very carefully designed. A lot of investment has gone into the design of these heat networks, and it is not an area that you would let your local heating engineer loose on and expect him to be able to deliver what the designers intended. The technology there is very sophisticated. You have the hydraulics, and then you've got the control methodology. You might have CHPs in there. If your maintenance engineers are not up to speed with that, they will do a lot of damage very quickly. So avoid using the cheaper, inexperienced providers. It will give you a hidden cost. That will generally be reflected in inefficiencies, which you won't see for a couple of years. And then somebody will say, why is my network running at 20% efficiency? Because you now have this total transparency on these networks. It is possible to benchmark networks and understand whether a network is running efficiently or inefficiently. There possibly is a move to focus in on those networks through reporting, and the heat network regulations require this sort of 4-yearly reporting process that will move on to analysing whether a heat network is operating efficiently or not. That will bring you right back to how the maintenance is being undertaken. And it will be a combination of maintenance and design. If the design is correct, then it's going to be the maintenance engineers who are responsible. If the maintenance engineers doing their job correctly, and it's still inefficient, then in all probability the system's been incorrectly designed. Okay, so you've got to look for third-party accreditation. Typically the ISO 9001, 14001, and 45001, which are all very relevant. You need a specific technical knowledge on typical heat/cooling networks. So making sure that any company is up to speed with them. You need qualifications via CIBSE and other professional bodies. So typically CIBSE do heat networks consultants. You want heat network consultants maintaining your kit so that you know it's done to a certain standard and they understand exactly what it is that they're doing. Record keeping, this is a big one, retaining information for review. We'll touch on this a bit later on, but it is necessary to keep records, typically, of any activities on the heat network. This is going to become more relevant as the efficiencies of the networks are scrutinized. There is a requirement under the heat network regulations now to keep records of any maintenance undertaken on a heat meter. And typically that includes replacement, but any activities. We will have a quick look at that in a second. So this is an interesting infographic, which is produced by CIBSE, and really it just covers the full cycle. I'm not going to go into too much detail on this now, but for you guys, commissioning is generally the point of handover, and then you take on this role of operation and maintenance, and you've got the customers here. This is the period of time, so you can see down below, so the operator increasing involvement to full-time involvement running for the life cycle of that asset. Okay, so I'll move on. Okay, so getting the most from a heat network. A heat network success is defined by consumer experience. So if they've got a reliable supply and it's a cheap source of heat, then they'll be happy. So if residents receive poor service, typically involving high costs and or unreliable supply, there is little interest in the low carbon benefit, meaning the whole concept has become flawed. So regular servicing of all plant equipment, not limited to the energy sector. So remember that a heat network is a loop of pipes running around the building with takeoff points that supplies all residents. That heat network is the property manager's overall responsibility, not just what happens in the energy centre. It does heating and cooling. This is very relevant. People assume that the cooling is down to residents. It won't be. That is depending on how it's set up. But generally, if it's a cooling network, you as a property manager will be expected to manage it. HIUs will improve system efficiency and reduce carbon emissions. That's hopefully the case. You need to make sure that those HIUs are maintained. HIU stands for heat interface unit. There is a thought going through at the moment that removing an HIU totally will improve the efficiencies. And I subscribe to that too. But as these systems develop, we will see how that pans out. So here we go. Use specialist support, preferably before handover. So avoid using gas boiler engineers. Contractors should conduct their work according to the following standards. So typically on a new build, if you're taking on a new build and it's got one of these energy centers, heat networks in it, it's a good idea to get your maintenance contractors, partners involved prior to taking it on so that you can get under the bonnet and have a really good look, see what's going on. So this is just a schematic of how these heat networks operate. I'm not going to spend too much time on this, but you've got an energy, center down in the basement here, and then these flats here with the HIU in each flat. Over here, you see you can take heat out of the HIU for underfloor heating or radiators, and then hot water as well. Okay, so it's almost like a combi boiler, but just without a gas supply. So getting the most from a heat network. Remember, apartment level metering means systems become transparent and efficiencies can be seen. So if the maintenance is not done to a good level, those efficiencies will reduce. That will translate to increased tariffs to residents. Check that all equipment is fit for purpose. So CIPSE Guide M standards. There are various checklists there which should be followed. Ensure the operation and maintenance manual is H&A health and safety compliant. This is a common problem where the O&M manual is lacking in detail, primarily because it's not possible on a small memory stick to assess how much documentation is included. So you need to double check that. You want to tailor maintenance routines to the plant, usually to SFG 20, which is the CIPSE standards. You've got to design a maintenance regime to cut energy losses and maximize efficiencies. Don't assume setup and maintenance plans comply with the standards. So this needs to be scrutinized and you need to check to ensure that it is thorough. Get to grips with the system pre-handover. Okay, so landlords' gas and electricity meters, when these are handed over, you want to ensure that all is operational, and you want to take a photo of gas meter and electricity meters as a recording at handover. Apartment level metering is maintained. Regular maintenance can assist in lowering resident energy use, reducing carbon emissions. Correct operation of apartment level metering is now a responsibility of the heat supplier. So you, as a property manager, managing agent, your client as the say the freeholder or head lessee will expect you to ensure that they comply with the regulations. The heat supplier does have a lot of responsibility on the heat networks. So you can arrange a specialist audit to identify energy, carbon and cost savings. So that's the ECCMs. Best practice audit should include recommended energy and carbon conservation measures. Okay, so that's generally on a proactive basis, looking at how the system can be improved. Okay, so we're almost there. Now this is a section out of the heat networks code of practice from CIBSE, and this is objective 6.4. There's a lot of objectives in this document, but for a heat network, it's to deliver a cost-effective, efficient maintenance of central plant that maintains a long life, which will improve systems efficiency, ensure a more reliable system, reduces environmental impact, prolongs life of the plant. So the objective is to deliver a cost-effective, efficient maintenance of central plant that maintains a long life. Summary of minimum requirements, maintenance regime in accordance with 55,000. This is a standard of, it does plan, do, check. Maintenance of assets to, when you've got the BISRIA and the Guide M code of practice, which is relevant here. Process of continual improvement to achieve optimum efficiency, including reviews of investment and monitoring against performance targets. So that's an ongoing process. Property managers would be driving that. Major plant maintenance scheduling. So ensuring that, for instance, the boilers are taken down, stripped down, that might result in disruption. That should be carefully planned. Continue to work on return temperatures. Now, this is integral to the operation of a heat network. A heat network works on what's called a delta T, and that is the difference between the flow and return temperatures across the network. So generally, the wider the delta T, the bigger the delta T, the higher the efficiency of the network. What you're trying to do is just supply heat to the demand and not oversupply. As soon as you get into oversupply, that's where you get the inefficiencies and other factors. An overheating building, for instance. Don't assume that an overheating building is as a result of solar gain within the building. It's probably to do with poor installation of pipework. Use of operating data to inform replacement and for feedback to designer. So the data, the extent of the data now is huge. Typically at heat meters, you can be bringing back data every sort of 15, 20 minutes, telling you what's happening on that network and monitoring performance. So BP, best practice, further process and monitoring to improve performance. So that's a sort of proactive approach. So this is where heat meters are very relevant. This is a little known requirement placed on managing agents, but the importance of this is that any heat meters within the apartments on the heat network fall under their responsibility as it's part of a heat network. And I think that probably overrides anything which might say within, say, a lease document that the tenant is responsible for the heat meter. The heat supplier is responsible for producing bills using that heat meter. So, accordance with regulations, ensure that any installed meters and cost allocators are continuously operating correctly and properly maintained and periodically checked for errors. Okay, so this is a fairly onerous responsibility. But look at 10.4. Heat suppliers need to keep evidence of maintenance activities, which include, but it's not limited to, invoice receipt, inspection logs and testing, all recalibration certificates and reports, and must produce them if requested by the OPSS. So that's the Office for Products Standards and Safety. They are the government body that is enforcing the heat regulations. So moving on, predictions for 2021 to 2050. So we've seen the introduction of the heat and building strategy, which just happened. All homes EPC band B and C by 2035. 66% of homes currently D or worse. Okay, review of overarching regulatory framework set out in the Gas Act. End connection of new build homes to natural gas grid. So that just reinforces the need for air source heat pumps and heat networks. Okay, clean heat grants, so investment. That is typically we've seen, I think, with the air source heat pumps, it's 90,000 homes get 5,000 quick funding or something. Okay, pilot a hydrogen town by 2030. And also hydrogen-ready appliances. Transformation program, so zero carbon fuel. You've got local authority heat networks only by 2025. That is already happening. And heat networks will become regulated by Ofgem. Carbon targets for managing agents and housing associations. So you guys will need to report more on your heat networks and how they're operating. That will be a measure on the efficiency of the carbon which is released, which will be determined by the standard of the maintenance. So that's it. Thank you very much. Thank you for listening. Are there any questions? Vicky, are you still there?
Yes, I'm still here. No, we have no questions at present. So I think you must have answered everything for everyone, Rupert.
Right. Well, it was a very pacey presentation. So I hope everyone's...
no, it's very thorough. Unless anyone has any questions that they would like to submit now, then I think we will be able to finish up.
Okay, right. Well, the email details are there to contact us if you need any information. But most importantly, I hope you've enjoyed it and it's been relevant.
Yeah, I have a copy of the slides, so I can send them out with a recording later today. Yep. Oh, we have actually just had one question pop up from Karen. It says, can you advise on the heat supplier, is this the RMC or also the agent who are liable?
Well, the RMC, so Residence Management Company, would probably by default be the heat supplier. If they're administering the service charge, so they're running the service charge, then in all likelihood they will be responsible as the heat supplier under regulations because they're recharging for the gas supply. Okay. The managing agent is appointed as the agent to undertake the heat supplier's duties. So whilst in legal terms the RMC is a heat supplier, the onus will be on the managing agent to undertake that completely in the, if you like, in the client's eyes. Okay.
Okay, yeah, I think that should help you, Karen. I will send out a copy of the slides so everyone's got your information there and your details if they have any other questions. So excuse me, with the recording. We do have another couple of sessions coming up this month and next month. So if anyone is interested in joining us again, please take a look on the News on the Block website and you can register there. Otherwise, thank you very much for your time, Rupert, this morning. It's been very helpful. Thank you everyone for joining us, and yeah, see you again soon.
Yep. Okay. Bye, everybody.
Thank you. Bye, Rupert.